Welcome. On the 3rd of May, the Sun produced an X1.6 flare, which is the 13th largest flare during solar cycle 25. Let's take a look at some of the details. The X1.6 flare was from active region 3663 in the northeast quadrant of the Sun. It peaked at 2022 UT on the 3rd of May. It produced an R3, which is a strong radio blackout in Eastern Asia. There was no proton event associated with it, which is somewhat surprising, seeing it was such a large flare. And it was associated with a CME a little bit later off the northeast limb. Here is a light curve in X-rays of the event. That's shown here with the red arrow. But there were also 3 large M flares either side of the event from the same region. So let's take a look at the sunspot region itself. This is active region 3663. This is a video taken by the Solar Dynamics Observatory HMI instrument. It's 2 days long. Note, first of all, the spot motions, the changes in spot size, and the changes in spot numbers. These changes all lead to more likelihood of flares. The optical images are taken at a temperature about 5700 degrees Kelvin. Let's take a look at slightly higher temperatures. This is from the SDO AIA instrument, helium-2 304 channel, which is about 50,000 degrees Kelvin. That is cool for the Sun, very cool. The things to note here are the formation of 2 bright ribbons and any ejecta from the region, which would be indicating there would be a coronal mass ejection. Next we'll take a look at the so-called cool corona at about 500,000 degrees. That doesn't seem very cool to me, but it's what's called the cool corona. This is using the Solar Dynamics Observatory AIA 171 angstrom channel. First of all, the thing to note here is the complex magnetic structure of this region and how it changes. And when the flare goes off, do you see a pressure wave move out, particularly to the northeast? Next we'll go to higher temperatures, so the so-called quiet corona. This is AIA 193 at about 1.1 million degrees Kelvin. Please note how much more visible the flare is as we go to higher temperatures. Note the motion of the loops after the flare shockwave has passed. Now we'll go to higher temperatures yet again. This is AIA 335 angstroms at about 2.6 million degrees Kelvin. Note the magnetic connections between the regions and that southern ribbon. You can actually start to see how the loops are associated and how that ribbon brightens as a result of the flare because of transmission of energy through those loops. Next, we'll take a look at the hot corona. This is at about 5.5 million degrees Kelvin, and you only generally see this during flares. Please note that the detector saturates. This is one of the problems with flares. is they produce so much energy that we don't see the details because they are hidden in the saturation part of the image. Last but no means least is the flaring sun. This is AIA 131 angstroms at about 10 million degrees Kelvin. Note there are pre-flare brightenings even at these high temperatures, and again the detectors saturate at the flare peak. So now we're going to look at the outer corona. So we're moving up in altitude. The image in the center of this is the original image of the sun, and the image around here is reflected sunlight off of radially scattered electrons. And so what we're looking for here is a change in the density as the coronal mass ejection passes through the outer corona. If you look carefully, you can actually see the flare on the disk and the resulting coronal mass ejection moving off to the northeast. Perhaps a clearer way of looking at this is to use the difference images. This is to take an image and then subtract the previous image from it. And we are here using the Soho LASCO C2 instrument again. You'll notice not only that there's a bright area, which is the coronal mass ejection moving out, there's also a darkening too. The flare has already had an effect on Earth. It produced an R3 radio blackout event over the Pacific Ocean and Eastern Asia and Australia as well. So this is quite common when there are big flares, but this one is a particularly large flare, so you would expect such an event to produce a major blackout event across the Earth. So what conclusions can we draw from all of this? We can expect more flares. Certainly some more M's and possibly some X's as well. The CME may impact Earth, and we have to wait and see whether it will. The initial indications is that we will get a glancing blow from it in a couple of days' time. It also shows that solar cycle 25 is not slowing down in its pace of activity yet. So that's it, folks. Until next time, stay safe and goodbye.